All right, ready and go. Okay, so let's go ahead and start. So when it comes to electrical circuits, there are three variables that we have to focus on. The first one is voltage, the second one is current, and the third one is resistance. Voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. Now volts can be represented by the letter V, amps can be represented by A, and ohms can be represented by the symbol omega. Voltage is the electromotive force in our circuit, and we're going to talk about what that means more later. Current is going to be the flow of electrical charge in our circuit, and resistance is going to be anything that opposes the flow of our current. Now, a common analogy when it comes to dealing with circuits is to think of a water pressure system. So here we have a water pressure system, and we can control the pressure with this knob. And you can see that when we're at low pressure, the output is going to be low as well. Now we can turn this pressure up, and what that's going to do is it's going to increase the flow of water through our system. Lastly, if we put some rock somewhere in our system, this is going to cause resistance, and it's going to decrease the flow of water in our system. Now we can think of the knob that controls the water pressure as voltage. We can think of the flow of water coming out of the pipes as current. And we can think of the rocks inside of our water system as resistance. So let's actually take a look at an actual circuit and find the voltage, the current, and the resistance. So the battery is going to be our electromotive force. It's what's going to cause these electrons to move around. It's what's going to cause the electricity. And that's going to be represented by voltage. We can represent the battery with this symbol here. Now the electricity caused from this battery is due to the movement of electrons. And we know that electrons are negative. So electrons are going to want to move from the negative end to the positive end. Unfortunately, when the convention was established, this wasn't common knowledge. And so as engineers, we draw the current going the other way, meaning going from the positive side to the negative side. And so current is going to be our flow of electrons from the positive side of the battery to the negative side of the battery, keeping in mind that the electrons actually flow from the negative side to the positive side. Now let's actually power something with our circuit. So let's put in a light bulb. Now this light bulb is going to oppose the flow of current, and as it opposes the flow of current, it's going to light up. And we can represent any type of resistor with this symbol here. And so there we go. In our circuit, we now have identified the voltage, the current, and the resistance. Now there is a way to relate these three variables, and that is through something called Ohm's law. Ohm's law states that the voltage is equal to I, the current, times R, the resistance. And with this equation, if we know two of the variables, we can use Ohm's law to figure out the third variable. Now we're going to be looking at two types of circuits, and the first circuit that we need to know is the series circuit. The series circuit, it was a joke. In the series circuit, electricity only flows one way. So let's draw a circuit here, and we're going to have our battery, and we're going to have two resistors. Now let's talk about the voltage, the current, and the resistance within a series circuit. The total voltage in a series circuit is going to be equal to the voltage drop across each of the individual resistors. So V total is going to be equal to V1 plus V2 plus however many resistors we have. Current in a series circuit is equal everywhere. So everywhere around our series circuit, the amount of flow going through that circuit is equal. Now to find the total resistance in a series circuit, all we would need to do is add up each individual resistance of each of our resistors. Now an example of a series circuits are Christmas lights. Christmas lights are hooked up in series, and this can be kind of annoying because if you somehow pop or blow one of the lights, all of the lights in the rest of the circuit will also go out. So let's go ahead and try a problem. Let's say we have a 12-volt battery. Let's say that this resistor that we have at the top here is 220 ohms, and the resistor that we have at the bottom is 470 ohms. And we want to figure out what is the voltage across each resistor, what is the current across each resistor, and the total current, and what is the total resistance. We can figure out the total resistance because the total resistance is equal to the sum of each individual resistor. So we can add up the 220 ohm resistor and the 470 ohm resistor to get us 690 ohms for our total resistance. Now if you look, we have the total voltage, we have the total resistance, And since we have two of those variables, we can figure out the third using Ohm's law. So we do 12 volts divided by 690 ohms, and we get 0.017 amps. Now since this is a series circuit, the current flowing through the entire circuit is even. Therefore, the current going through resistor 1 is 0.017 amps, and the current going through resistor 2 is also 0.017 amps. Now, how do we figure out the voltage drop for resistor 1? Well, we have the current for resistor 1, and we have the resistance of resistor 1, and since we have two variables, we can again use Ohm's law to figure out the third. So if we get our current times our resistance, we get 3.83 volts. We would employ a similar strategy with the voltage drop across resistor 2. We would take our current times our resistance. So we get 0.017 volts times 470 ohms, and we get 8.17 volts. Now to check, the total voltage should be equal to the voltage drop in all of the resistors. And we can see that if we add up the voltage drop in resistor 1 and the voltage drop in resistor 2, they equal the total voltage. Alright, let's talk about a parallel circuit. So in a parallel circuit, there are more than one branches that the electricity can go through. If you've ever used a power strip, the power strip allows your appliances to be hooked up in a parallel circuit. So you can have a TV, a telephone, and a refrigerator all hooked up to a power strip, and this would be a parallel circuit. I don't know why you would have a TV with your, well, I guess you would want to watch TV while you're doing laundry or something. So again, let's talk about voltage, current, and resistance when it comes to the parallel circuit. So voltage in a parallel circuit is the same across each component of the parallel circuit. Now in a parallel circuit, the total current is equal to the sum of each individual branch's current. So the total current is going to be equal to the current in resistor 1 plus the current in resistor 2 plus the current in resistor 3, and so on and so forth. Lastly, the resistance. If you take the reciprocal of the total resistance, that is equal to the sum of each individual resistance. So let's do a problem again where we have a 12 volt battery and we have a 220 ohm resistor and a 470 ohm resistor. So we know that voltage is equal across the entire circuit. So the voltage drop in resistor 1 is going to be 12 volts, and the voltage drop in resistor 2 is also going to be 12 volts. Now we can find the total resistance. So the reciprocal of the total resistance is going to be equal to 1 over 220 ohms plus 1 over 470 ohms. And if we do this math, we should get 149.85 ohms. Notice the total resistance is actually less than the values of each individual resistor. Alright, so we have all of our voltages, we have all of our resistances, and so since we have two of those variables, we can use Ohm's law to figure out all of our currents. So our current across resistor 1 is going to be 12 volts divided by 220 ohms. This is equal to 0.055 amps. Our current for resistor 2 is 12 volts divided by 470 ohms. We can also see that if you added up current 1 plus current 2, it would equal the total current, and that's in a parallel circuit. Now the last thing we have to talk about is power. Power is equal to the current times the voltage. I hope this video was helpful. If you want a copy of the animation, you can find it in the link in the description below. Also, a lot of time and resources go into the creation of these videos. So if you found any value at all in these videos or learned something, please consider following me on Patreon. I would like to increase the production value of my videos, and a way that you guys can help with that is by following me on Patreon. We are going to be doing stress strain calculation. You gotta make sure the tie.